Welcome students to your favorite channel Pradeep Sir Classes has PSC, and today we are going to discuss about the numerical king series, that is thus AC Verma solutions, and it is Gauss's law. Okay, so it is question number 12 and is a more interesting concept, that is spherical charge distributions. So what is about spherical charge distribution, that is surface charge distribution it is related to? And first of all you have to write down the question, that is question number 12. Okay, so then students, question number 12 is a charge capital Q is placed at the center of an uncharged hollow metallic sphere. Oh yes, it is question number 12, and this is there is a sphere and a charge capital Q is placed at the center of an uncharged hollow metallic sphere. So it is uncharged and hollow, and this is a metallic sphere. So this is a term uncharged. First of all student, uncharged means there is no charge on the sphere and it is hollow. Hollow means there is no charge, it can contain within the particular sphere, within the inside the particular sphere. So here it is capital Q charge, means the charge is at that particular point. Okay, so this is uncharged, means there is no charge, it is not uniformly charged, or there is no amount of charge on the surface. And next one is it is a hollow and the metallic sphere. What is the meaning of metallic sphere? That is, it is a conductor. If some amount of charge is given to that conductor on the outermost surface, then charge is uniformly distributed. Okay, so this is the main point. So this is an uncharged hollow that is evacuated from the inside, and it is a metallic sphere. So if some amount of charge is given, then charge is uniformly distributed. Okay, so the next part is of radius, a sphere of radius. So its radius is small a, it is also given. And find the surface charge density on the inner surface and on the outer surface. Okay, so students, if you still now write down that particular question, then go back and write down the question again, because you have it will be better to realize that one. So you have to calculate charge density inside. So charge density, we can write as sigma inside the sphere. So if Q charge is given, Q charge is kept at the center, then minus Q charge is induced within the inner surface. So minus, this is minus charge inside induced within the inner sphere, and amount is minus Q. So charge density equal to minus of Q by total surface. So surface area equal to 4 pi a square, since it is a sphere. So the surface area of the sphere is 4 pi a square. And for the next part, you have to calculate surface charge outside the sphere. So outside the sphere, since the sphere it is uncharged, so the net charge on that particular surface is 0. So since it is minus Q, then here it is plus Q. So plus Q charge induced outside the sphere. Okay, so it is so simple numerical, but the concept is a greater importance. So this is plus Q are uniformly distributed over the sphere. So it is plus of Q by 4 pi a square. Since it is uncharged, so for an isolated system, the net charge remains constant, and that is it is a neutral, so minus q plus q equal to 0, but the inner surface density of charge is minus of q by this one, but the outer surface charge density is this one. And the next part, this is A and B, and if a charge small q is put on the sphere, so q charge is put on the sphere, so q is positive, so the net charge for the outside surface now becomes q plus capital Q, okay. And we know that charge always resides on the outer surface, so the outer surface, the charge of the outer surface, so charge for outer surface, this is this one, and charge for inside one, it is minus q. If a charge small q is put on the sphere, what will be the surface charge densities on the inner and the outer surface? Find the, and so this is the second part. So A number part is inside and outside, and the B number is, you have to calculate inside density. So it is will be 4 pi a square, but the outside one is positive, and it is q plus q by 4 pi a square. Okay, student, since the outer charge is small q plus capital Q. Okay, I think the concept is clear for you. So the next part is you have to calculate for the next one, find the electric field inside the sphere at a distance x from the center in the situation A and B. Find the electric field. So students, you have to calculate electric field at a distance x, for the first one means when capital Q charge is alone at that particular point, and the second one is when small q charge is given for the later time. So for the first portion, see, the electric field at x distance is equal to 1 by 4 pi epsilon naught into capital Q by x square. Since it is the expression for a point electric field due to a point charge, so what will be the electric field due to a point charge? There is 1 by 4 pi epsilon naught q by x square. Since at the center there is a charge of capital Q, then at a particular point, there is from x from the center, the electric field at that point will be this one. And for the second one, if q charge is given, then all the charges are distributed, and we know that for that particular charge, inside electric field is 0. Why? Due to the cell theorem. What is about cell theorem? So suppose, student, this is a cell, and if we calculate electric field at that point, suppose there is a charge and there is a charge, there is a charge and there is. So this charge can repel this one, and this charge also repel this one, this charge also repel this one, this charge also. So the electric field at that particular point is 0. If you think yes, that if that particular point is at that point, then this force is a less amount and this force is greater amount. Similarly, this one and this one, and the contribution of all the charges kept at that particular point is less amount than that one. So the contribution for that part cancels that part. So if the point is anywhere within the spherical surface, suppose there is a charge, there is a point here, and all the charges are distributed over the sphere. So if we cut this one, then contribution of that particular one is along this direction, and the contribution of all the charges acts along this direction. Since the distance is less, but the charge is also less amount, so that particular force due to that particular charges is along this direction, cancels this one. So the electric field at that point is also 0. Or simply you have to think about within a charge conductor, at any point within the within that particular sphere, electric field is 0. So the contribution for the small q charge, the electric field is 0. So the second part, the answer of the second part will be same. So Ex equal to 1 by 4 pi epsilon naught Q by capital Q by X square. So for the first one, this will be the answer. For the second one, this will be the answer. So when capital Q charge is at the center and you have to calculate electric field at that point, then the answer is this one. And if small q amount of charge is given at that point, then the answer is same. Since this charge cannot create an electric field within the sphere. Okay. So I think all the concepts related with spherical or distribution of charge due to some amount of charge is given at the center or any fan within the sphere, you can calculate this type of numericals. And wait for the next class, that will be start from 13. Okay. So thank you and subscribe the channel. And last of all, I want to say continue your study and wait for the next one. Thank you, students.